So how many people here have heard of TypeScript? Can you please raise your hands? All right, so that's 2 hands. All good?
I'm just looking at the volume.
Cool. Did the other people not hear the question, or did they have they actually not heard of TypeScript?
We're just keep going. I'm just going to play with the audio.
Go for it. I'll just keep the questions coming. How many people here use JavaScript daily at their job? All right, so that's a significant amount. More people, hands have gone up. I'm just going to share my screen now. So can I start, David? Yes. All right, perfect. So one of the key things that TypeScript offers you is, like, JavaScript is not without its faults. We all know that. So it just gives you less what. And before you ask what is what, it's stuff that makes you go like this. Instead of stuff like this, where you go, oh, it's stuff like this. And I actually showed this to a fellow, and he said, this one's better than the other one. But still, this is not what you want. So JavaScript does have the concept of errors. And this is an error that I'm pretty sure that every one of you has experienced at least once. You call a function on something that doesn't exist. JavaScript will throw an error. The execution in that particular stack will not continue. Anybody know what the answer to this particular expression in JavaScript would be? So probably shouldn't have gone with a question answer kind of a presentation, because you guys have to be mute. Surprisingly, the answer will be an empty string. Makes sense. You sum two arrays. One rational answer could have been an empty array. Another rational answer could have been an error. But JavaScript gives you an empty string. Here's another random example. If you sum an array and an object, what do you think the answer is going to be? Well, the only possible rational answer seems to be just throw an error. But JavaScript will chug along and just give you this string. Here's another one. It seems like it's the inverse of this particular thing. And addition is a plus b is equal to b plus a. Guess not. It's number. If you sum two objects, like, this is where it gets even weirder. If you run it in Chrome, it's going to give you this string, whereas if you run it in IE, it's going to give you, it's not a number. JavaScript has its flaws. One of the good things is that you can sum a string and a number, and the concatenation is reliable. It works with negative numbers as well. And this allows you to do string concatenation with numbers quite easily for UI representation purposes. But does anybody want to guess what this is going to be? Before you guess, it's not a number. It's still going to run. It's not going to throw an error, but it might not be what you expect it to be. And like, the argument that people give against TypeScript is, we can use linters for JavaScript, and they can point out these errors up front. But can we lint this? You don't normally write simple expressions like this. You have functions where variables come from different places. So over here, you're passing in an array and an object, and the function is going to internally add these two things. And then, as we've seen, it's not going to throw an error at this point. The error is going to be at some point in the future. Similarly, like, these objects might not even be here. They might be coming from other variables, and these variables might actually be coming from the server. So you need some form of telling the compiler, your linter effectively, that this is the type that I want for this thing, and you should not allow me to do stuff that this thing doesn't support. For example, an array does not support addition. Don't let me do it. And that's where TypeScript comes in. TypeScript is effectively just a linter on steroids for JavaScript. So all of these examples of valid JavaScript code that we saw are actually going to be TypeScript errors. They're going to be compile times errors. You're not going to run into runtime issues with stuff like this. But it's more than just a linter. It's also what they call a transpiler, which basically means that you get to use future versions of JavaScript compiled down to the JavaScript that your current JavaScript engines, such as the user's browser, can actually execute. For example, for a functional language, you keep writing the keyword function quite a lot in JavaScript. There's this thing called an arrow function, as you can see over here, this particular thing, which just transpiles. Like if you pass it through the TypeScript transpiler, you'll just get the same thing, but it's just easier to type. And it's not just about easier to type. It's also got there are new features in JavaScript which actually help prevent bugs. One of them is the let keyword. So here's a piece of code where I have an array of functions, and I'm just going to create 3 of these functions. So I less than 3. Create these functions, and each of these functions is supposed to log out the variable I. Now you would expect that when I call all of these 3 functions, they would log out 0, 1, 2, but they'll actually, all of them will log out 3. And that's because the variable I is actually shared between each iteration of this particular loop, because the var keyword in JavaScript hoists the variable within the scope, within the outer scope. In this case, this whole block over here. Whereas there's a new keyword in JavaScript called let, which for this particular thing, each I is going to be different. So this particular I is going to be the value, going to point to the reference of I that's created when this particular function was pushed onto the functions array. So this time it will actually log out 0, 1, 2. An argument that people present when we say that TypeScript is a transpiler that you'll actually want to use is that, well, if I wait 1 more year or 2 more years, my users will have these modern JavaScript engines. Why should I use TypeScript right now? Why not just work off of JavaScript and continue to work off of JavaScript, and as new things come in, I'll start using them? But there's always going to be this gap between what version of JavaScript the user's browsers can support and the JavaScript that you actually want to write. Stuff like that let keyword, stuff like the const keyword that you want to use today so that you don't have bugs in your code. To bridge this gap, you use something like a transpiler, and I'm suggesting that you use TypeScript as that bridge. One of the so the 2 key value propositions of TypeScript are its awesome JavaScript linting and its transpilation of future JavaScript to the current JavaScript versions. However, people have started to become accustomed to transpilation, so they're okay with that part, but they will still have arguments about, I don't need static safety, I have tests. Well, they're not the complete story, right? You can make tests pass in horrible ways, and it's all green, but it doesn't fit. And you want something more than that. You can never provide really good documentation without mentioning types. Here's, thank you, Matt. Here's a simple example of a function that I've pulled out of NPM leftpad, which is quite famous right now for various reasons, where the arguments for this function are str, len, and ch. So this is a function that's supposed to pad a string from the left-hand side. I'm actually hitting myself back, and that's slowing me down. That's fine. So it takes a string, it takes a length, and it takes a ch. So the types are actually encoded in the variable names, even if you're not telling them to the compiler. So with JavaScript, there's nothing stopping you from writing code like this. You could write this, and it would work fine. It's just a function that takes 2 arguments and then sums them together. But you don't write it like that. You actually write stuff like this. You want to mention that I'm going to take 2 numbers. And you give this to TypeScript, that's going to be perfectly fine with it. But you can do more than that. You can actually add type annotations to tell the compiler that never let anybody call this function without a number. And here's another argument against testing, not against testing, but testing versus types. Types are just another form of testing. type annotation for a particular function is just a theorem, and the function body is a proof. So the function body holds you to that claim. So if, for example, if a function takes a number and another number and returns a number, it's going to ensure that the function must return a number. And another claim that people make why they don't need types is that conventions are more powerful and less obtrusive than types. Well, how are you going to write your conventions? You can write stuff like this, that people's name should be display name. People should have a user ID. But I'd rather just document it in code, like have a type declared that the person is something like this. And then I get to use it within my code and have that effectively tested by the compiler that nothing is going to call this function with a wrong object structure. And like the reason why people hate types is they've been burnt by bad types that really move the slider towards convenience, towards soundness instead of convenience. They won't let you do stuff which you obviously know, just let me write this, I know what I'm doing. They'll force you down stuff like this, like here's a piece of Java code that you have to declare throws exception at 3 levels because Java makes you. That's not what TypeScript is like. It can infer as much of your types as possible. For example, like there's no type annotation over here. You just declared a variable foo and you assigned it to a number. TypeScript knows that foo will be a number. And you can ask TypeScript to move completely out of your way. You might get code from some other source or a junior developer or the developer who left, and you don't understand what that is. So in that case, you can just simply annotate that particular variable as any, and then it's fine. Like you can assign a number to it, you can assign a string to it, and then if at the feature point you call something that you expect to be on a number and it blows up, but if you want to migrate that code to TypeScript, that's perfectly fine. TypeScript will not complain about this thing because you told it that this particular variable was of type any. You just told the compiler that I'm driving, just get out of my way, and TypeScript will move out of your way completely. And then it's another convenience thing is that how many times have you had a model and then you had a view model and then you wanted to convert that model to a view model, and then you kept coming up with stuff like automapper, mapper.net, monomapper, and stuff like that. If you have structural types, TypeScript has a structural type system. So types are matched based on their structure, not by their name. So over here I have a variable called foo and a variable called bar. If I were to go ahead and annotate this as foo is of type foo, and bar is of type ibar, I'd still be allowed to do foo is equal to bar is equal to foo. And TypeScript will be perfectly fine with it. You will not get any errors in cases like this. So let me just jump into a quick demo at this point. Before I do, though, because I cannot hear you guys, does anybody have any questions? Cool. All right, let's just jump to the demo. So here I have just a simple piece of JavaScript code. It's just one file. And this is purely for demonstration purposes. Does anybody see anything wrong with this particular piece of JavaScript? Like, let's just start with this line. I want to zoom in. Yep.
Basarat, can you go full screen on your browser?
Yep. And Alt F, I believe, and Shift F.
However you do that.
Yep. So,
Yeah.
One thing is clear, that it's not easy, like I've proven upon that it's not easy to review just plain JavaScript. I'm going to go ahead and just convert this particular piece of code into a TypeScript. I'm just going to rename the file into a TS file. And what you'll notice is that as soon as the TypeScript compiler kicks in, it's going to notice that you're doing a bunch of things wrong over here. So let's just look at the first one. It's saying that the argument of this particular type is not usable because it specifies a property called read only that does not exist on this particular function. So it's actually getting that because define property is defined within lib.d.ts. So basically the TypeScript team has gone ahead and written declarations for what exists within the browser, all the browser APIs. So that's there. So it's picked up the definition for define property, and it's picked up that you're passing in an object that doesn't have the right value. So let's just delete that. Let's see what actually exists over here. So if I delete that, so here are a few things that exist here. Are probably meant to write writable. So let's just make that writable. And since it was read only false, it should be, oops. And that was not good. Nope. This is why I don't do full screen. Going back here. Tab. So if I go back to the top of the file, and great. I'm just gonna so read only false, probably meant to write writable. True. That's one bug fixed. Here's another one. What's the error? HTML element is not assignable to parameter of type string. Parse int takes a string, but someone's actually passing in a DOM object to this. They probably meant to get the text content for this particular thing or something else. What is it? Text content sounds it. I don't need to remember the case of C over here as well. I don't need to remember that writable doesn't have an E if I'm not a native English speaker. Similarly, there's an error over here as well. Someone's applying the single or the arithmetic operator when they're probably meant to apply OR. So that's that bug gone. But you'll notice that there's more that we can do over here. So email address, an email address or an array of email addresses, that seems like an excellent candidate for a type annotation. Let's just put that in. So now that we have the type annotation, we've told the TypeScript compiler that email address can either be a string or an array of string. It's gone ahead and figured out 2 more bugs for us. And this bug over here is actually, the comment pretty much explains it. If it's an array loop over it, this person probably thought, being a junior dev, that email address.length is something that you can use to identify if it's an array or not. Actually, length exists on a string as well as an array. So the right way to do this is to actually use the array function. Now, once you've applied that particular constraint, and I've missed a bracket, so that's just complaining. So that's good. Doesn't have to fail at runtime. And then it's gone ahead and figured out that email address within this particular block has to be a string array because you use this particular type card. You said that only come here if it's an array. And over here, it's figured out that it has to be a string because it clearly cannot be an array. And the only 2 things that we've said that it can be are a string or a string array. So now over here, we have another value is of type number, and we're trying to call it. Someone thought that value would be a string because that's how they're using send email function over here. So what could cause that? This person probably came from some other programming language, or like he might be a professional developer, like an expert developer, but because he's using multiple languages, he's forgotten that the for each in JavaScript, the value is the first thing, the array index is the second. But I don't even need that. That's not used, so I'll just delete that. And now value will be a string, and now value.trim will be a proper function, and TypeScript will be fine with it. So that's pretty much the demo. From that, hopefully you've seen some value in using TypeScript just as a linter, as a documentation system. It's going to save you errors. And the editor that I've been using is actually ALM. So if you want to play around with TypeScript, you can just npm install this, and you don't even need to install the TypeScript compiler. You should have an IDE and everything. So that's like the whole experience that you saw was just with that single npm install. So I'm going to go back here to the slides. And that is it. Thank you. Does anybody have any questions? I'm going to struggle to move out of full screen.
Okay, you just missed the applause. Sorry, I had you muted.
Ah,
Is there
cool.
any questions?
Thank you.
Questions at all? So there's a question about the ALM tool. So do you just want to describe a bit more about what you're getting when you install the ALM tools?
So what you're actually getting is a command line executable that that effectively hosts the IDE for you. So you give it a TypeScript project or a JavaScript project, and it gives you a browser entry point. So like as you saw over here, no, it's all other tabs are open. I think if I just go back over here, it's running off of localhost something, and then I have it running on the command line over here from a folder. So it's actually serving that folder up to my browser and then doing live linting. So if I go ahead and type in let foo is equal to 1, 2, 3, and then foo is equal to, let's just try and assign a string to a number, and you'll see that you'll get an error over here. That's what everything is giving you. So it's a good starting experience specifically designed for TypeScript.
And that's something you've written yourself?
Yes. You don't have to use this. So the TypeScript compiler is perfectly open source. It just goes to show how much pluggability you have with the TypeScript compiler. You can create your own IDE on it if you want. You can, like for your own organization, you can do stuff that makes sense for your developers and automate your JavaScript workflows.
Any other questions, Basarat? Well, thank you, Basarat, for your time. Thanks for giving us a bit of an introduction to TypeScript.
Thank you.
And it's also our first remote presentation here at Marcelina, so I was a bit nervous as to whether it was actually going to work at all. So thanks for being a guinea pig.
No worries.
All right.